Welcome back to the second video. Now we're going to look at purification and separation techniques. So when I went on a trip to South Africa, I drank bottled water every day because it was said that the water wasn't clean. When we look at these many brands of water, is there any difference between them? One is natural mineral water, one is natural spring water, and others are even better since every drop is pure. Now, how do we tell if something is pure? If you recall, a pure substance is something that contains only one substance. That means if it's pure water, it only contains water and not other minerals. Now, let's do a quiz on what do you think pure water would look like. Now, a pure substance contains a single substance that is not mixed with other substances. So, if you're looking at pure water, and in this case, distilled water is pure water, it will only contain one type of particle. Now, you can see that these are all the same type of particles. And if you remember, H2O or water contains two hydrogens and one oxygen. So you can have this Mickey Mouse shape as well here. So you can represent it like that as well. Now, an impure substance like tap water will contain many different types of particles. So it contains water, and maybe this is salt, and maybe this is sugar, or any other kind of mineral. So this is what we call a mixture because it contains two or more substances. And this is what we're going to look at purifying and separating using these techniques. So it will be a physical separation. Now, why is purity important? Now, most of the time it's important so we know whether something is safe to eat. Now, drugs have to be very pure. A drug called thalidomide was marketed as a sleeping pill. But because it contained another molecule that was very similar to it that made it impure, the other substance caused many miscarriages in pregnant women. Now, I'm sure you know this tea, the Taiwanese milk tea that you can buy at 7-Eleven. I don't know if you remember, it was banned in 2016 due to the presence of a food additive called L-theanine, which had untested effects on the body. Now, I'm sure if you take a look at anything you're drinking, the list of ingredients have a whole lot of stuff you might not know about. Wouldn't that be dangerous if no organization such as AVA for Singapore tested if these things are safe? So, if a chemist at AVA would want to test if a food or a particular drug is pure, this may be one of the ways he would do so. You might test if the solid melts at a fixed temperature or the liquid boils at a fixed temperature, or perform what we call chromatography to check whether it consists of a single substance. We will see more of how each one of this works in the next few slides. Now, if you're looking at a solid, if it's pure, when it melts, it will melt at a fixed temperature. So you can see that when it melts, the temperature remains constant here. So for example, when ice melts at 0 degrees, it will continue to be 0 degrees until all the ice has become water. However, if you put, for example, salt on ice, and that's what most people in cold countries do to remove snow on the roads, the melting point goes below 0 degrees. So if this is 0, that will be below 0 here. And it will melt over a range of temperatures. So that means maybe somewhere at -4, it will start melting, and your temperature will keep going up to 0 or maybe slightly above 0 before all the ice becomes water. Now, similarly for liquid, it has a fixed boiling point, meaning pure water will boil at 100 degrees all the way until all the water becomes water vapor. So if you look at the temperature time graph, the temperature remains constant until all the water or all the liquid becomes a vapor. But if it is impure water, for example, salt water, in this case, the boiling point of water will be raised. So it will be slightly higher here, maybe at 102 degrees, and it will continue to boil as the temperature increases to maybe about 105, 107. The temperature is not fixed before all the water becomes water vapor. Now this is a good thing if you like to cook, because if you add salt into water, the boiling point of water increases. So you can cook food faster because your water remains at 100 degrees and 101 degrees Celsius. Now let's do a quiz to recap before we end this section.